Hello, and welcome back to the 2023 International Fuel Ethanol Workshop and Expo podcast. I'm your host, Danielle Piekarski, and today I am joined by Jonathon Speed, Director of Product and Applications at Keit Industrial Analytics. Jonathon will be presenting on two panels at FEW this year. The first titled Unlocking the Increased Ethanol and Co-Product Throughput Found at the Nexus of Captured Operational Data and Plant Control, where he will speak on what real-time measurements of chemical concentrations allow plants to optimize, and that presentation will take place at 3:30 p.m. on Tuesday. The second panel Jonathon will speak on is titled Ensuring Optimal Catalyst Performance at Biodiesel, Renewable Diesel, and SAF Production Sites. And that takes place Monday afternoon at 3 p.m. The focus of this presentation is real-time online measurements of renewable diesel and SAF pre-treatment feedstocks and how to fix the problems before they affect your catalyst. And that will actually be the topic of today's podcast. So without further ado, I'd like to introduce Jonathon Speed. Jonathon, thank you for joining us today and welcome to the podcast.
Thank you. Thank you for having me.
Of course. So let's get started and have you tell us what are the challenges associated with the process of converting triglycerides into renewable diesel, and how can pretreatment facilities and modules address these changes?
So the thing about converting triglycerides into renewable diesel or sustainable aviation fuel, and I'm sure we'll find another use for them soon as well, we're not just feeding in pure triglycerides. If we were, it'd be really easy. If we had 100% of just one triglyceride going in, you wouldn't need to pre-treat. You could feed it straight in, put it onto a catalyst, hydrogenate it completely, and take it out as fuel. The problem is what we're actually trying to do is use waste. So we've got used cooking oils, we've got tallow, you might have a mixture of the two, you'll have some virgin crops as well. It might not all be the same. You might have sunflower oil, soybean oil, canola oil, but there's loads of different things all coming into this together. I've even heard talks of taking in molten plastics at some point as well. They may well have, if you're lucky, just chemical contaminants. You may even have bits of stone, various other things. So it's not pure. You try and pass that over a catalyst, and the poor catalyst is going to get shredded. It's going to be poisoned. It's going to be blocked up. It's not going to work. And in order to know what you're about to put onto your catalyst, you need to measure what goes into it. There's a famous quote by Lord Kelvin from a couple of hundred years ago, that which cannot be measured cannot be controlled. And that remains true to this day. So if you're feeding in, let's take, for example, you've got tallow. You may have some bone in there, a bit of phosphate in there, phosphorus, a bit of calcium, a bit of iron from blood. All of those are going to block a catalyst, and they're going to render it basically dead. And these catalysts are $1 million a pop. They're not cheap catalysts. So the pre-treatment, it's basically a combination of washing and filtering. The guys that make these are going to not like me saying it like that, but that's really all it is. It's industrial scale washing and filtering. And by pre-treating, we take out the phospholipids, we take out phosphates, we take out metals, and what you're left with is as pure a triglyceride mixture as you can, so that when you feed that over your catalyst, it's going to come in nice and clean, it's not going to kill the catalyst, it's not going to deactivate it, and it means your catalyst will keep running for as long as it possibly can. And in order to control those pretreatments, you need to know what's going in. You need to then set the residence time. Some of them have chemical dosing that you're putting in. Put in the right amount of chemical. Is your separation running properly? There's a lot there. It's basically a bit like an edible oil refinery bolted onto the front end of a hydrogenation plant. So it's almost two plants in one. But by having all of these steps, you're able to take dirty, messy, complicated mixtures and then clean them up so that when you do the hydrogenation, you know what you're going to get out. Bit of a rambling answer there, but hopefully that's kind of gathered the reason why pre-treatment is so important for renewable diesel.
Yes, that was great. Thank you. So moving forward, are there any limitations to the current methods of sampling incoming feedstocks? And if so, how does the use of an online and real-time process analyzer overcome these limitations?
So this is where it gets really exciting, or at least for me. I mean, I'm a chemist by training. I'm a science geek. I always will be. But so we're at this dawn of this cusp called Industry 4.0, and the idea is real-time measurements are key to unlocking the fourth industrial revolution, real-time control, even artificial intelligence-based control. But stepping back from that kind of destination that we're heading towards, it's all about real time. So if we take, let's take the metals, so phosphorus, calcium, magnesium, maybe potassium, sodium, the way we measure those in the lab today has stayed the same for the last 50 years or so. And it's ICP, inductively coupled plasma. You take a sample and basically you burn it. And it's just like fireworks. We all know that fireworks are different colors because of the metals inside them. This is exactly the same, but in a lab. So you take a sample, you burn it, and you look at the amount of the color that comes out that's proportional to that specific chemical you're trying to measure. That means you've got to take a sample from your process, take it to the lab, measure it, get the result, go back to the control room and let them know. So best will in the world, half an hour. More realistically, maybe it's 3 hours between taking the measurement and getting the result. And we don't use sat-navs that tell us we should have turned left 3 hours ago. That's not helpful. That would be infuriating. You want your sat-nav to tell you should be turning left now. And it's exactly the same. And sometimes errors happen, mistakes happen. If you're taking a sample from molten oil, because that's what this is, and it's molten fats, you then take it from the sample, which is hot, it's dangerous. By the time you've got it, it solidifies. Has it separated out in taking it to the lab? Is it still representative? If it is, and you get it into the instrument, have you accidentally contaminated it? That can happen. If you then get the result you're not expecting, and I've genuinely heard this from some of the manufacturers and the producers, if they get the result they're not expecting, they just ignore it. Because, something probably went wrong. We'll ignore that. We'll wait 3 hours and we'll get another one. At which point, you might as well have not taken it. So online and real time gets over that. It gives you context. That's the way I like to say it. It's the online is great because it's directly where you want to measure. No extra plumbing required. We don't put pH probes in loops. We put them directly in the pipe we care about. The same goes with temperature probes. The same goes with flow meters. But the real time, if you're taking a measurement every minute, every 2 minutes, if you get a weird one, well, wait 2 minutes. Get another one after that. And you can see, is this process actually changing? Is it really changing in that direction and something strange is happening? Or was that an artifact? Was it an air bubble? Was it a lightning strike that caused some weird fluctuation on my voltage or something? Because these things happen. And that's the big difference. It's that real time. I like to say it's a measurement with context. It tells you what happened before, what happened afterwards. And from that, you can start to make a decision about it. Whereas discrete samples, they're better than no samples, but real time is better than discrete. So it's like that sat nav thing. Why would you not do it now? Why would you wait 3 hours to be told something's gone wrong?
Absolutely. Great answer. And I liked your firework metaphor as well. So the last question we have for you is, what are the potential use cases for the online and real-time process analyzer, and how can it prevent any damaging material from coming into contact with the catalyst?
So this is where most production engineers really get excited when I start talking to them. The online measurement, you can calibrate a spectrometer. So that's what I work with. It's a spectrometer. And you can calibrate it to become a universal analyzer for everything. And that's why I'm speaking in multiple panels, because the same piece of equipment can be used for different applications. So in renewable diesel, you can calibrate it to measure phosphorus, the metals. We can definitely do total metals. The jury's still slightly out whether we can differentiate between metals, but we can definitely do total. As I say, measure phosphorus, water, if that's of interest, free fatty acids, polyethylene, and all of these different contaminants affect the process in different ways. So if you've got free fatty acids flowing into your hydrogenation, that's not really a problem. You'll hydrogenate those anyway, but it can cause corrosion. So you can then measure total acid number. You can use that for preventative maintenance. If you know how much acid is coming in, you can start to account for it and repair a pipe before it becomes damaged, rather than waiting until afterwards and you have a problem. If you want to measure the phosphorus and the metals, so phosphorus, if you're doing degumming, to remove it that way. If you're adding phosphoric acid, you can then work out how much phosphoric acid to add. You know the correct amount. And ironically, if you add too much phosphoric acid, you lower the pH too low, and then you've got to bring it back up again by adding sodium hydroxide, or caustic, in order to wash out the phosphorus. There's a whole wealth of data around that. It's really interesting. But if you can measure it, you know how much to dose. If you're further downstream, if you were doing degumming, you're now at the bleaching. You can measure there to work out the residence time in the bleaching, how much bleaching earth to add. Bleaching earth is actually a consumable. You load it in, and then afterwards you have to get rid of it. It does have a tendency to spontaneously catch fire, so you don't want to throw it away if you don't need to. And you've got to throw it away in a safe way. And if you're upstream of bleaching, you can work out how long the residence time is. If you're downstream of bleaching, you can look at breakthrough. And that's your final safety net. That's the point where you're going, hang on, phosphorus has got through here. I need to divert to a different tank rather than waste my catalyst. We've managed to get detection limits for phosphorus down to about half a ppm in real time. So that really does allow you to see what's getting through the pretreatment. Is something about to hit my catalyst? And it's that kind of final, it's like slamming your hand down on the big red stop button. You could do that at that point and divert, especially if you've got a much higher breakthrough. You know, if you had 10, 15, 20 ppm of phosphorus coming through at that point, you might have a problem that you really want to enact and do something about. But it is genuinely a case of you can measure pretty much anything. There may well be things I've not thought of here. And also downstream from hydrogenation, if you're doing alkylation and you're reforming the diesel and you want to turn it into a particular octane rating or a particular product, you could even measure there as well and use that for fine tuning. If you're fractionating between SAF and renewable diesel, you can measure there to get the right balance as well. If you think about spectroscopy as a universal chemical concentration and physical property measurement, because physical properties are empirical based on the chemical concentrations, the world really is your oyster. There are hundreds of different applications, and we've only just started to scratch the surface, which is why for me it's so exciting. And we're now beginning to roll out and do work with the manufacturers and the producers themselves. And that's what I'm really looking forward to, coming to FEW, coming to the diesel side of the conference as well, and talking to everyone. So it really is quite exciting. And I'm, as I say, every time I talk to someone, I'm learning new ways that we can use this technology. And over the next 12 to 18 months, it really is going to be very eye-opening as to what we can achieve.
That's awesome. Thank you. Again, we are joined by Jonathon Speed with Keit Industrial Analytics. Thank you, Jonathon, for joining us today.
You're welcome.
And for those who would like to hear more on this topic, make sure to tune into Jonathon's panel, Ensuring Optimal Catalyst Performance at Biodiesel, Renewable Diesel, and SAF Production Sites at 3 p.m. on Monday afternoon. I look forward to seeing you, Jonathon, at FEW, and thank you to all our listeners. We hope to see you at FEW as well.